On frameBuilder's main menu, click Open to file hallway_G0. It is the base frame of hallway. Samples. Frame 3df_42j_hallway_G0. Open. Click number 2 geometry. This is the base frame. Change the resolution from 800 pixels to 600 pixels, then, resize, and relocate, the dialog box. First, let's put some information on the screen. Under the green joint tab, there is a green eye, click at it, check the joint number. Joint numbers are displayed. Click this eye button again, click member, and select member numbers. Member numbers are displayed. Number 1 step, assign 2 fixed supports. Click at the fixed support located at the middle of the action buttons. Use the fixed support cursor to click at joint 1 and 3 to make them fixed supports. Number 2, remove middle column. Click at the arrow button at the upper right corner. Use the arrow cursor to tag the middle column. It is tagged. Right-click, select member command, select remove. The middle column is removed. If you change your mind, click at the undo button of the action button. Click undo. The middle column is back. Click the redo button next to it, the middle column is again removed. Using the undo, redo button, you may change your mind anytime. Note that the undo, redo buttons are reset after the frame is saved. So, you can only change your mind up to the latest save. Number 3, raise the middle of the roof 24. The middle of the roof is joint 5. Click to tag joint 5. Right-click to select joint commands. Move/duplicate. Here, joint 5 is the tag joint. Step number 1, check the move button. Step number 2, specify the displacement of y equals 24 inch. Step number 3, click the move button. The middle joint is moved. Number 4, split each of the roof beams into 2 pieces. To connect 2 braces, we need to create joints on members 1 and member 2, so that braces can be attached. The attaching point is located at the middle points of these 2 members. To do that, first, click the blue X button to clear all the tags. Then, use the arrow cursor to tag members 1 and 2. Let's assign member properties first. Members 1 and 2 are made of W10 by 22, a 36 steel. Right-click to select member commands, assign properties. Here, members 1 and 2 are tagged. For green number 1, click A36, then, click the blue Assign Material button. For green number 2, to the left is the customized section property library maintained through Program Quick Look. Here, we have a standard AISC member. Let's select W10x22, then, click the blue Assign Material button. The reason that you want to assign properties first is because we are about to split these 2 members into 4 members. After the split, the new members will inherit the properties of their parent member. Now that the materials are assigned, we want to split each member into 2 pieces. On this member command dialog, the Split tab is located to the right of the Assigned Properties tab. Click to select the Split tab page. At the top, it says, Members 1 and 2 are the tagged members. Just above the green number 1, the frameBuilder reports the length of the first tagged member. Length of member 1 is 130.23 inches. This time we want to split each member equally into 2 dot pieces. For green number 1, check the first option and specify 2 equally spaced sub-members. For green number 2, click Split. We are back to 2D graphic editor. The roof members are splitted. Number 5, split each of the 2 columns into 2 pieces. The first piece is 170 long. Again, click the blue X action button to clear all tags. Click the blue T button. This blue T button enables you to select structural elements according to their attributes. For members, the choices are vertical, horizontal, section material, no section, no material, and beta not zero. For our case, tag vertical members. 2 columns are tagged. Right-click and select Member Commands, assign properties. At the top, members 3 and 5 are tagged. For green number 1, select a 36, click blue. Assign material. For green number 2, under AISClib, select W10 by 33, click the blue Assign section. For green number 3, look to the right, and for this structure, all of its members have a beta angle equal to 0. Again, click the Split tab page. At the top, members 3 and 5 are tagged. The length of the column is 220 inches. For green number 1, the attachment point is 170 inches from the support. So, we check the second option and specify the length of the first sub-member is 170 inches. For green number 2, click Split. Back to the 2D graphic editor, columns are also splitted. It's time to connect 2 braces. Number 6, connect 2 braces and make them pin connected at both ends. Click at the blue X action button to clear all tags. Now, click the action button of M+. The cursor turns into M+. Use M+ to click at joint 9, then, joint 7. A new brace member 14 is connected and tagged. Again, use the M+ cursor to click at joint 10 and joint 8. A new brace member 15 is connected and tagged. Both are tagged, let's assign properties. First, click at the arrow cursor. Right-click and select Member Commands. At the top, members 14 and 15 are tagged. For green number 1, select a 36, click blue. Assign material. For green number 2, under AISClib, they are 2L, 2.5 by 2.5, by ½ inch. 2L, 2.5 by 2.5 by ½ inch, then, click the blue Assign section. Because these 2 braces are pin connected on both ends, click to select the End Connection tab next to the Properties tab. For green number 1, check both ends pinned. For green number 2, click the button Define Connections. We are now back to the 2D graphic editor. This is our typical frame. Let's click the blue check button next to the Undo button. This blue check button checks the completeness of the model. Its response is, the model is complete. This blue check button only exists in the 2D graphic editor. Click the Save as Action button to save it to hallway_typical. Type the name. Hallway. Typical. And then, click the green button Save As. This button exists only in the 2D graphic editor. If you want to save a frame under a different name, do it in the 2D graphic editor. We are done with the typical frame. Click the red X button and back to the main menu. In this overview, we want to explore how to use the 3D graphic editor. On frameBuilder's main menu, click Open to File Hallway Typical. Samples. Frame. 3df_42j_ hallway file hallway typical. Open. Click number 2 Geometry. This is the typical frame of the hallway. Change the resolution from 800 pixels to 600 pixels, then, resize, and relocate, the dialog box. This single typical frame was built in the previous training video, and is in the XY plane at z=0 inch. Let's view the 3D graphic editor. Check the 3D graphic editor box located at the top left of the dialog box. 3D graphic editor presenting the 3D ISO view of the structure. Let's rearrange the screen to show these two graphics side by side. Uncheck the 3D graphic checkbox, the 3D graphic dialog box disappears, check it, it appears. The action buttons in 3D graphic editor are similar to that of the 2D graphic editor. So, what you have learned from the 2D graphic editor is applicable to that of the 3D graphic editor. Back to 2D graphic editor, let's click at the I action button, click joint number. Joint numbers are displayed. Now, click at the M+ button, use this M+ cursor to click at joint 1, then, joint 6. A new member is connected. Move to the 3D graphic editor, next to the I button, there is a refresh button, click it, and the new member is there. On the 3D graphic editor, click the undo button, the new member is gone. Click the redo button, the new member is back. When we make changes in the 2D graphic editor, the 3D graphic will also be affected. However, the tagging in 2D graphic editor is independent of that of 3D graphic editor. And vice versa. This way, you may act on different sets of tagged elements on 2D and 3D graphic editors. The next step is to duplicate this XY typical frame to 4 places, each duplicated frame moving 180 inches in Z direction with respect to the previous one. Additionally, we ask frameBuilder to connect interframe members. This duplication can be done in either 3D or 2D graphic editor. They are identical. Let's use the 3D graphic editor. In the 3D graphic editor, click the blue T button, select Tag All Members. All members are tagged. Right-click and select Member Commands, Duplicate. At top, 10 members are tagged. For green number 1, specify the distance of Z equals 180 inches. For green number 2, repeat 4 times. For green number 3, check to connect interframe members. For green number 4, click the blue duplicate dot button. Take a look at the 3D graphic editor, a 3D frame is connected. Go to the 2D graphic editor, click the blue check model button. Many members are now not completely assigned. These are the new interframe members that connect duplicated frames. Let's use the 3D graphic editor to fix this problem. Look at the 3D graphic, we have interframe members connecting among supports. We don't need that, let's use the box button to isolate them, thereafter, tag and remove them. There are 2 action buttons unique to the 3D graphic editor. The first one is shaped like a box, the box button. Next to it, is the viewpoint button, it is a picture of someone looking through a telescope. Let's use the box button. Click the blue X action button to clear all tags. Let's cut a frame at Y equals 0, elevation of supports to box in the members at base. Click the box button, for green number 1, check manually define a rectangular box. For green number 2, it consists of 3 panels, the first panel, defines the range of X coordinate, the second panel, defines the range of Y coordinate, and the third panel, defines the range of Z coordinate. For example, to the left of the first panel is a list of X key coordinates, drag a key coordinate from this list, and drop it to populate the from or the to entries. It establishes the boundary of the X coordinates. The default range is from the lowest X key coordinate to the highest X coordinates. That is the full range of the structure in X coordinates. The default box contains the full range of X, Y, and Z coordinates. The structural elements on the box boundaries are included. For our case, we want to include only Y equals 0 members. So, in the middle panel, drag the Y equals 0, and drop it to become the to value. Click the green number 3 refresh button to refresh the graphic. Sure enough, only the button members are included. Next, click the blue exit button to confirm the box definition. On the 3D graphic editor, click the blue T button, select Tag All Members. Right-click, select Member Commands. Remove. All the members are removed. Click at the box again, click the blue Include All button, and then, the blue exit to confirm the new box selection. The whole structure is now displayed. Base members are gone now. For 3D graphic editor, the default viewpoint is at point 1, 1, and 1. This is the ISO view. Let's try different views. First, the one-click views at the bottom. Click View XY, this is the XY plane view. Next, click View XZ, this is the XZ plane view. Next, click View ZY, this is the ZY plane view. Done with the one-click selection. Next, check the view from a point in space. For this one, the coordinate of the viewpoint has to be specified. Let's type it. Specify 1, 1, and 1. You will get the ISO view. Change Z to become 2, the view changes accordingly. Change the viewpoint to become -1, 1, 2. The view changes again. That's the idea. The box button is very powerful. Because you may slice the model into smaller boxes, and construct them accordingly. Work box button with the point of view button, it is easy to construct a complex model. Back to define the properties of interframe members. They are all made of W10 by 22, A36 steel. Let's use the blue T action button to tag members missing material property. Click the blue X button to clear all tags. Next, click at the blue T button, select tag member, no material. Members without material property are tagged. Right-click and select member commands, assign properties. For green number 1, select A36, and click the blue Assign Material button. For green number 2, select W10 by 22, and click the blue Assign Section button. Back to the 2D graphic editor, click the blue check button, the response is, model is completed. Click at the Save As button to save the structure as hallway. Click at the red X at the top, and we are done with model geometry. You are now fully capable of using frameBuilder to solve all types of structure problems.